Okay. Hi, everyone. So I'm going to give you a story today about an incident that eventually led us to build a system, an application to make cities safer. So back to June 14th, 2017, a colleague of mine phones me up very early in the morning and he says, "Have you seen the news this morning?" And I was like, "No, I haven't seen the news." He says, "Turn the television on." This was on television. So this is the Grenfell Tower fire in central London on June 14th, 2017, the worst fire in London since the Second World War. He'd ask, why did he phone me up on that morning? Well, a year before this fire, we had built a new control system in the regional water supply network, which supplies that area, and Grenfell is in that area. So, of course, we were a bit anxious about that. So, and because, like most cities, most countries, the water supply system provides the water to fight fires. Well, the system we built was built to respond to fires, that it would detect them and completely open the system, providing the maximum volume to fight a fire at a building. And it did work. But it became evident after the event that London Fire Brigade didn't really have, were not readily, or the information wasn't readily available about which hydrants were the best hydrants to connect to generate the maximum volume to fight a fire. But that got us thinking, because we had done some work on this over the previous years for Thames Water, who run the water supply system in London, calculating how much water was required to fight a fire in individual buildings and what water was available from the water supply network, total volume, to fight that fire. So we got to thinking we could build a system, but we'd have to do it at scale. And we were asked to do so, and that led to this. So we built a digital city of the whole of Greater London, 1.7 million buildings in the entire water supply system, so that we could analyze firefighting requirements for every building and the firefighting availability from the water supply system for each building. Now, the individual digital buildings, you can see we were able to accurately map the external geometry of the buildings pretty accurately. Some of you might even recognize you're in Westminster, you're looking at the Houses of Parliament and Big Ben next to the river, and then a little bit further back and to the north, it's Buckingham Palace at the end of the mole. So when we did then embed the fire codes, or in the UK we call them the National Firefighting Guidelines, into this system so that we could calculate the fire requirements in each individual building. I'll come back to that in another couple of slides. But also, our digital system had some side benefits. We were able to embed important information to support firefighters in individual buildings. So here's a large tower block in Westminster, and we embedded the floor plans for that, different floor plans for that building, and the fire safety management and fire risk assessment for that building. And we also can embed information about the firefighting infrastructure or fire escapes. And we can even take this even further, and we can build complex geometrical models of buildings inside the digital city. You can literally fly through them. You can turn walls and floors off and study the internal architecture of the building. Where are the staircases? Where are the fire escape routes? Does it have sprinkler systems or hose reels? And we can attach information to different parts of the building which might be relevant to firefighting. That's the digital city. So the things that we need to consider to answer the questions that were raised by Grenfell. And these are the things. So first of all, the fire services have certain protocols about how they fight fires. They're fairly generic amongst fire services around the world. There are rules to how they set themselves up to fight fires, how many hydrants they will connect to, how many hoses they will run from a hydrant, whether they'll consider to use a hydrant in case there are obstructions to laying hoses. We'll come on to that again in a minute. Also, you need to know about the geometry of the buildings. Okay, so we have that from the digital city. We know how high the buildings are, and we know the footprint of the buildings from that already. And you need to know what the use of the buildings are. That fits into the fire codes. Now, we were able to map the customer database from Thames Water into our digital city, because they keep a record of building use, because they charge people differently depending on how the building is being used. So we mapped that to Digital City, so we had all the information to calculate the fire requirements of individual buildings. Now we needed to find out how much water was available to fight fire. So we built a digital model of the entire water supply system. So, but when network models normally just tell you about pressure and flows in the systems. These are fire models, so they're specifically set up to analyze fire flows for individual buildings. And if you're looking at the blow up on the left-hand side, you'll actually see a pumping station and a water network, but you'll see these funny little lines jotting off at 45 degrees. They're not pipes, that's the fire hoses. The fire hoses connecting the network to the fire engines. So we analyze what actually turns up at the fire engines, because that's different than what comes out of the fire hydrants. And then we built this whole system into what we call the fireflow application. So what does the fireflow system do? So this is an online system available 24/7, which the fire brigade can log into, and it calculates the fire flow requirements for every individual building. It analyzes the network to identify which hydrants are valid. So basically, if the fire hydrant's too far away from the building, or there's an obstruction, like a major highway, railway tram line, canal, river, any water body in fact, they won't lay a hose to that hydrant. So it only analyzes valid hydrants, and then it will calculate the total volume of water, the best volume of water you can get to fight a fire at that building from those hydrants where you can lay hoses to. If the building fire requirement is too high, the building goes into a risk register, and then the fire brigade can take mitigation measures to fighting a fire at that building. It's a live system, so the dispatch can access the system, and so can the fire engines, so they can actually pick the location in which they want to fight a fire at a building, and then it will draw the routes to the best valid hydrants and calculate the maximum volume of water that they will be able to achieve at that location to fight the fire. And just think of the possibilities. So we already have an online survey system which links into this. So you can load it onto your phone or onto a tablet. And so you can see here on the right-hand side, our engineers can identify buildings when we want extra information about the building. That goes to the surveyors in the field, then they use the app to enter that data about the building. So how many stories, what's it being used for, does it have fire tanks, fire boosters, that sort of thing. They send it back directly into the fireflow system, gets embedded into the digital building. We can also, at the moment, we suck the data in, the SCADA data in out of the Thames SCADA system into our fire models, and we run them intermittently and update fireflow. But we know we can link these two in real time so that we can run the models as and when required. Might say it's 6 million model runs to cover the whole of Greater London. So we only want to really do the models when we actually require the information. And that's something that we're planning for the future. And also we can store other information. So we can store information about the power supply to buildings. But more importantly, in this instance, these are drawings which are identifying the gas infrastructure linked to a multi-story building. When the fire brigade turn up, they want to know where the isolation valves are so they can turn the gas off before they start fighting the fire. So our fireflow system is part of our sort of smart networks initiative. It's a system that we've built where we can analyze the relationship between infrastructure and buildings, identify risks, and then take mitigation measures to improve safety and resilience of the city or of cities. Fireflow has been used to test planning applications for new developments. And actually during COVID, when they converted a major conference center into a COVID hospital, they used fireflow to test whether that was a valid conversion, that there was sufficient fireflow for a change to that use. So at the moment, fireflow covers all of Greater London. So 1.7 million buildings, 8 million people. In a few weeks' time, we'll start to roll that out across the whole of the Thames estate. So this time next year, it will cover 15 million people, just under a quarter of the entire UK population, about 4.5 million buildings. And I always say about fireflow, 9 more fire services. So there'll be 10 fire services who have 24/7 access to this system to pick up information about fireflow. Now, I always say about this system, when I'm asked, this system doesn't stop disasters. This system gives the information to the fire services about risks, certain specific risks, which they then can take action to mitigate, and hopefully then there's no disasters and I won't get one of those phone calls again. Okay, thanks very much. So questions?